We're live. Here we go. All right, so when we go through this, let's start. This feels so weird. Describe how you would use a random number table to conduct this simulation. What would you do? Yes. That's okay, and there are multiple ways to do this. Okay. Beautiful. So what we're talking about here is because on our problem, we do, in fact, have those nice multipliers. We have 30%, 60%, 10%. You don't need to use two-digit numbers. And in fact, it's probably better not to use two-digit numbers, because if you do use two-digit numbers, you risk having to use many more numbers. And if you're given a limited table to pull from, sometimes that's not what you really want to work with. Okay, did anybody else assign their numbers differently rather than the 0, the 1 through 3, and then the rest of them? Anybody do something different? Yeah. And that's perfectly fine. You don't have to follow a specific order. It's actually kind of neat when you don't do that, because that way we can see what would occur with a different set of steps. And again, our number table is supposed to be, generally speaking, random. So we should be okay. Did anybody use two-digit numbers? Okay, so there were a lot of people that used two-digit numbers. That's okay. Again, it will still work. But you want to be careful how you assign those numbers. If you're doing two-digit numbers, how would I assign the idea that 10% of the nests have no eggs? 00 through 09. Good. Just want to make sure that we're all on that idea that 00 counts as 1. Don't go 00 through 10, because that just messes it up a little bit. Perfectly fine. Here's my next question. Repeats. Repeats are okay? Because we've got to think about this. Does each number represent a specific nest? What does each of those numbers represent? The amount of eggs in that nest. It's a characteristic. Can characteristics repeat? Yes. If I wanted to do a number generator to describe what kind of hair color you have, how many of us have brown hair? Quite a few of us. Can characteristics repeat? Yes. No, I'm the only one that's allowed to have brown hair. You must pick another color of the rainbow. Okay, I would rather probably pick another color of the rainbow. I'd have that unicorn pretty hair, where it's blue to pink to purple. That would be me. No? You can't picture it? Sure. Hands down. Make that bet right now. Everybody get a 5. I will do rainbow hair. Of course, unfortunate part here is I don't find your scores until the middle of summer. We'll come back. Okay. He's like, he's going to be back. There you go. All right. So there are, yes. Sometimes. It's based off of the question that you're dealing with. If your numbers are representing, for example, a specific individual and you're forming groups, you're not going to use the same individual twice. Okay? If I know for a fact that I have 6, candies in my bag, and they're all wrapped. Once I take one candy out, I'm not going to use that one again. I can't eat the same candy twice. Although we may wish that is the case, doesn't work that way. Okay? So again, you've got to ask yourself that question. Is a repeat okay? Is it a characteristic or an individual? So here are my 3 trials. And again, the big thing that I kind of want to see is I need to be... Yes, sir. Uh-huh. Yep. It shoves them all together. If you want to bullet them out, you can. It's just that sometimes bulleting it out takes even longer. So if we're looking at our thing, so the component is going to be an egg. Looking at an egg, and we're trying to identify the characteristic of that egg. I'm sorry, a nest. Sorry. Yeah, this is what happens when I don't read the whole problem. I'm in your boat with that. Okay, Yeah, no, it's okay. Keep going.
Because with this one, I listed it all out because it made more sense to me.
That's
It would take more time to condense it.
That's fine. It's whatever way works best for you. You do need to make sure that you identify the component. So we're talking about representing number of nests visited. So we are kind of talking about nests that we're dealing with here. It should have been a little bit clearer in there. That's not really good. We have explain the model. So we're explaining how we're breaking it down. Go until, stop when, some type of thing like that. Whether or not repeats are okay. Explain how the trial will run. We're going to do it several times, counting the number of nests visited. And then define the response variables also in there. Then we just do, this is several trials. Okay, so this is basically steps 1, 2, 3, 4. First 4 steps are in here. Then we have step 5, basically. And then 6 and 7 is your conclusion. Okay? They've got it written down here. I usually write it on top or wherever I have room. You do want to record what you got from each of those, especially for counting, like we get a value from each of them. So that way, if I'm going through here and I notice that you did yours the exact same way that I did mine, but for some reason you have a different answer, I can go back through and figure out why. Where did that occur? Was it a mistake on your part? Did you do something differently than me? How big of a mistake was that? And that's why both the AP exam and I will do those on tests and quizzes. Because if we're doing a random number generator in your calculator, then I got to do it a different time for every single one of you. And ain't nobody got time for that. Okay, so this kind of like streamlines our answers a little bit. And again, we're talking about, okay, I got 13 eggs. That's really not the most important thing. The important thing here is it took me 7 nests to get to those 13 eggs. Because again, we want to have at least a dozen good ones. Okay? State your conclusion. Since it was asking me for my question, go back, here we go. Estimate how many nests he will have to visit. When we're talking about estimating something, that's usually an average. Or if they say about how many or what should we expect, those are going to be your averages. So you just simply take your final answers and take the average of those. Yes, ma'am? We could get into and argue decimals all the live long day. The reason why, what if we're talking about people? Well, maybe that like 0.8 of a person, I don't know, maybe somebody was just really, really large. Maybe they're missing a limb. Maybe somebody's pregnant and they're on the way to creating another individual. I'm not going to fight that battle. You round however the heck you want. Okay? There is going to be a point in time in this class where I specify, in this case, you must always round this way. I'm not going to get into the philosophies of rounding people. It's just too much. Then what would you, as long as you round it to either 8 or 9 and not like 17, we'll be okay. All right? All right. Sweet. Okay. And I do apologize. Or wait, what? Do we need one more? Nope. There we go. Animation. Gotta love it. I do apologize for being so delayed in getting the homework answers up on Canvas, but I did post them yesterday, and the whole unit is now posted. Okay? All right. Okay, so all we're doing today is practice. We're going to practice as much as we can. Our quiz is going to be, I think it's a half hour. So as long as we stop at, let's say, 8:20-ish, maybe a little bit before then, we're going to do as much practice as we can get through. That is the whole goal. All right? But before I start talking about practice, I do want to point out one thing that's in your notes. It's the next big assignment that's kind of coming up. So today we're doing these 2 pages, or as much of it as we possibly can. On the back of that, you will see that we have our first investigative task. The investigative task is similar to an AP question. In the AP exam, you have 6 multiple choice questions. The 6th one is worth a little bit more, and they actually call it an investigative task because it's like this. They set up a general situation, and then they ask you to answer multiple pieces dealing with that, where one answer builds on the other, which builds on the other, which builds on the other. So this is your practice for this. This first one is probably going to be a little bit uncomfortable because you're not quite sure yet what to expect. That's okay. You want to make sure that you always address the W's in something like this, so that you're talking about your context. When I say address your W's, that just means statistics, no matter what, you're going to be wrong if you don't have context. Okay, so make sure you get that in there. And then as you look through this, you will see that I actually have you written down exactly what I expect for every single section. And hey, look at this. 1, 2, 3, 4, 5. 25. Maybe that means each one of those is worth about 5 points. This one is worth 20 points, but that's because the procedure itself is going to be 10 points, and then each of those are 5 points. Because if you get that wrong, these aren't going to happen. Compare the results to a standard of proof. A standard of proof means in the very beginning, you say, before I even do this, what would it take to convince me? That is my standard of proof. Okay, so before you even get going, you read through this problem and you say, what's the context of this? And you ask yourself, what would it take to prove to me that this person blank? This problem up here is going to be difficult to wrap your brain around. But once you wrap your brain around it, it's going to fly out. It's just going to go bam, 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 bam. But it's that first idea of what we're talking about today, actually, the whole idea of describing your model, that's going to be the hardest part for you. So we're going to practice that a lot today. You're welcome to come in and ask me questions. Your investigative task is actually going to be due next week, Tuesday, so on September 10th. Okay? These will be submitted online through Canvas. So if you haven't gotten Canvas figured out, you need to do that because that's how you're going to turn it in. You're going to type it in. The tables are going to be either in Excel or Word or whatever. The only thing I ask is that when you submit, the only things I will accept is doc, DOC, DOCX, or PDF. Do not send me a link to your OneDrive account or to your Google account. Save it as a PDF or whatever and upload it. Okay? All right, so here we've got NASCAR. That'll be fun to anybody listening at home. All of a sudden, I just got really loud into the microphone. What up, sir? I'm probably going to be speaking gibberish, and that's why a lot of times what I will be doing is repeating, like what you guys say, because it's not. I mean, it's a cheap mic. It's not like a $200 sound system. I wish I could have, like, with some classes they have like the mics dangling from the ceiling. I don't know if you've ever seen one of those for the distance learning classes. Those are really neat. I was in a classroom once that was doing distance learning, so it was that classroom plus a classroom across the county. So we had microphones so they could hear the students. So, but yeah, hey, it's not perfect. It's a heck of a lot better than nothing. Okay? All right, so here we've got some NASCAR problems, and this here is going to be, again, very similar to your quiz. Read through that for me, please, to yourselves. One thing I want you to notice from this question, it's basically a yes or no answer, right? Even if you get the right answer, yes or no, you get no points unless you kind of justify it. It's not about what your actual answer is, it's the work that goes into it. Because I can randomly say, yes it is, and not have a thing, an idea what I'm talking about. I'm going to show me you know what you're talking about. And this is the way that the general problems will be presented to you. They might just say, here's the situation, answer the final question. So what we need to do here is we need to not look at the answers. Sorry, I thought it was going to give me like questions through that. We need to kind of devise a plan of action to work through this. So let's think about our steps. What's our first step? Identify the component. So what is it that I'm going to be doing over and over and over again? Buying a cereal box. So each component is going to represent a cereal box. We're just going to assume that there are no mistakes at the company and that every cereal box has exactly one card in it. Somebody's popular today. Do not disturb people. I feel like it's yelling at me. Phone in the back. All right, so we've got a component is a cereal box. Now we want to explain the model. 1-digit, 2-digit, 5-digit numbers. What would you like to do? Do what? Single-digit numbers. Okay. Now, do you have, for this one, I didn't specifically give you a table of values, did I? So you have a choice. What digits would you like to use? What makes sense to you? How many folks do we have up here? 5. You can do this several different ways. If you're using your calculator is frickin' amazeballs. In your calculator, there we go. How do I get to my random number generator? Because we're going to have to use it no matter what. You're going to do math, prob, and then we've got these guys down here. Because can we have repeats here? Yes, because that's the thing, is you might get the same different boxes with the same people over and over again and not get the one that you want. So repeats are okay. If you don't want repeats, you would go to this one. So I'm going to go to 5. Now what's really nice about these calculators is you can tell it what numbers you want to use. You do not need to say, I'm going to use single-digit numbers. And I'm going to let 0 and 1 be Jeff Gordon. 2 and 3 be Dale Earnhardt Jr. 4 and 5 be Tony Stewart. 6 and 7, Danica Patrick. 8 and 9, Jimmy Johnson. I don't have to do that. Because all of them are equally likely to appear, what else could I have done? 1 through 5. I can tell my calculator, I want the lowest number that you can give me to be 1, the highest number that you can give me to be 5, and just for the sake of simplicity in counting how many times it took, I'm going to say give me 5 numbers per line. It is only giving me those digits. So when you are using your calculator, make life easy. If everything's equal, just use the numbers that you need. If you're using a random number table, then you've got to think about single digits or double digits. So you've got this written out in front of you, that Jeff Gordon, Dale Earnhardt. I want you to assign numbers to those people however you want. We're all going to have different answers because we all have calculators that are hopefully mixed up so that we're not starting in the same place in the algorithm. Yes, because that means yours hasn't been used before because that's the first time mine has been used. Unless you really want to have exact answers like mine. Calculators are up front for you guys to use. I do need to know, is there anybody in here that will need to check out a TI calculator for home use? Because I can do that. You could just keep them at home, but it's like a textbook. It's your responsibility. You lose it, you pay for it. Anybody in here need to check out a calculator? Okay, I needed to find out how many I need to get. That's all. So they don't give them away to another class. Anybody else? I've got 1, 2. Okay. Keep going. All right. So we should have our numbers listed out, how we decided to break it down. who you assign to what numbers. Heck, if you wanted to use your calculator and say, because my lucky number is 13, I'm going to do 13, 14, 15, 16, 17. Fantabulous. You're strange, but go for it. Okay, you can do that with the calculators. All right. Now, I need to know a couple of things. Did you tell me which numbers to use in your instructions? Even if those instructions are as simple as assign the numbers thusly, or that way, or like so, and you just write the numbers next to the words. That's fine. Like I can say, I am going to assign the numbers, pen is usually a good idea, 1, 2, 3, 4, 5. Assign the digits 1 through 5 like that. I can write that down as my steps. But you need to tell me what you're going to be representing it with, because this is identifying the model. Once we do that, you need to tell me, what am I going to be doing? How long am I going to keep grabbing people? Or grabbing cereal boxes? What did I want? Until you get all 5 drivers. Not dryers. They're not standing there drying your clothes out. Okay? So what I'm going to say is for me, I would say I would assign the digits 1 through 5 so that they represent like this. And I'm going to use a random number generator where each number is a cereal box, and I'm going to go until, that's a very important thing, go until I have one of each of those numbers. I need a statement in there about repeats. Are repeats okay? Yeah, so then I would need to say, repeats are okay. So let the numbers 1 through 5 represent a cereal box where each of the numbers represents the driver on the card inside, assigned as that. I'm going to look at a random number table, generator, whatever, recording values, go until I have one of each. Repeats are okay. The response variable. What am I going to be recording through each of these trials? What's your question? Right, how many did it take until you had one of each of those? So I'm going to say, record how many boxes it took to get one of each of those integers, or one of each of those numbers. And then I do it. So for me, what my page would look like is kind of like this. I would have just written the numbers straight on the paper like I showed you. And I'm going to say I'm going to use, if you don't have a random number table, you need to tell me what command you put in the calculator. Even if it's just that, like what's that string that showed up, I don't really need the third number, I just need the first. This is telling me I'm using random integers from 1 through 5. I don't care how many times you had it pull out for you. And again, we're going to keep going until we get all 5 of the labels. Repeats are okay. Recording the number of boxes you had to open. Context, 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 context. So far, so good? Okay. There it goes. Now, my results shouldn't be the same as yours. This is literally what I got out. And when you do this, when you're recording your things, I want to see the numbers. I want to see the numbers that you get, which is why for tests and quizzes, I typically give you a table. Because again, that's just irritating. I want to write down a whole bunch of numbers. Gosh, if it took you 50 times, how obnoxious would that be? That would really suck. And so you see here, the first 4 were nice. Those were distinct. Those were different numbers. And then I started repeating myself. And then I started repeating myself. And then I started repeating myself. Not funny? No? Okay. And it took me 9 boxes, thank you, including that last one, to get all of them. And then we're just going to do it a couple of times. Usually I'll tell you. On this one it says Nothing about how many times you should do it. Usually I'll tell you 3 trials. Sometimes I'll say 5 if it's something quick like this. Okay, and you'll see with each trial, I recorded how many times it took me. Now, my question specifically at the very beginning of this was, a NASCAR fan decides to keep buying boxes until she has all 5 driver's cards. She is surprised when it takes her 23 boxes. If I look at this, should she be surprised if it took her 23? There's a couple of different ways you can state your answer here. You're saying no. Why not?
Because it's random and the averages are the same.
Okay. It's random. The averages are like the same. Somebody got another reason why it would be not surprising? Yes. Okay. On his first trial, he got 23. So if you look at this, I did 5 trials, and within those 5 different times that I did this, one of the times it took me 22. 23 is just one more than that. You had 23. How many of you did a trial and had more than 23? So we do have people that happens. So it's going to come down to, and again, this is going to be based off of your responses. If your responses were like 12, 15, 13, then you might say, yes, I definitely think that's surprising. None of my trials came even close to that. Okay, you can do that. It's going to be all about how you justify your answer. For me, I would say, and again, I can argue this both directions. I never had to buy more than 22 boxes. So if you're claiming it took you 23, I think you're a liar, liar, pants on fire. Or 23 is just one more than 22, so that shouldn't be surprising. Or my average of this is going to be somewhere around 15. And that's pretty far from 15. We're going to be talking much more specifically a little bit later on about what defines unusual. Okay? That will come around. So it says the fan should be surprised about how many she had to buy. How are you doing with that? Okay, please listen to what I'm talking about here, because a lot of people don't believe me when I say this. If you do not include context, which is generally where you're talking about identifying your component and describing your response variable, you don't tell me what numbers I'm allowed to use and where you're getting those numbers from, whether it's from the random number tables that I might give you or your random number generator in your calculator using a specific command. I need to see that. You need to spell out for me your assignment of values. And included in that is go until and are repeats okay. So this one, go until you have one of each. Go until you've shot 5 baskets. Go until you've run 5 miles. Whatever it is you're looking for, I need to know, when are you going to stop? Or stop when you have 3 of that one. And then our repeats okay. Okay, you want to use that language. So what I want you to focus on here, because we're not going to have time to do like a full process from start to finish, I want you to just describe to me how you would assign your values. Ronan. Come on, the next problem. So I want you to describe to me just how would you assign those values. Really silly question? Are you given a number table for this problem? No. That actually makes your life easier. Okay? It's recyclable. It's okay. My next big question for you. Are repeats okay? Are they individual people? Or are they just characteristics? If I have somebody numbered person number 5, am I going to hire person number 5 twice? Person number 5 might want 2 paychecks, but person number 5 don't get 2 paychecks. So again, yes, we're talking men and women, but we're talking about specific men and specific women. Yes, ma'am. Mm-hmm. I would say let one component be an applicant. Let that range, since there are 22 applicants, let the numbers 0 through 11 represent a man. Or no, let's just do 1 through 12, because I can use whatever numbers I darn well choose. 1 through 12 to represent one of the men, and then 13 through 22 represent the women. Mm-hmm. It's okay. How many of these numbers am I going to select? No matter what, I'm going to select 3, but no repeats. Okay? We're gonna, because what it's saying is, should I be surprised if I happen to get all women? Okay, yes.
So if we're analyzing, it has to be like found the average and stuff, but this
You might not want to find the average. You might want to look at it and say, in all of my trials, did I ever have all women just by chance show up? And you can say, well, what was the likelihood of that occurring? Well, in my 10 trials, twice I had all women. That's a 20% chance. That's not too surprising. Again, I'm going to be defining for you what surprising is. Okay? No longer is it up to your discretion. I will tell you when to be surprised and not surprised. But for now, there are a lot of different ways that you can argue it. This is, again, in context. But if you're thinking about this, we're looking at 1, 2, or 3. 0, 1, 2, or 3 could be the outcome for a number of women. Taking the average of that, it's not going to tell me very much. You're right. Okay. So here's my answer, all typed out because I hate sitting there writing for you. And again, you would not need to write all of this. I would say let each number from 1 through 22 represent a person hired or an applicant. Okay? Then I would say, this one says I'm going to look at a random number table. And to make my life easier, since I'm only interested in the numbers 1 through 22, I'm going to ignore all of the others. So you can do that. You can say, I only care about those numbers, so let's ignore everything else. Your percentages will work out. Or you could just say, I'm going to let the numbers 1 through 10 represent the women, 11 through 22 represent the men. It doesn't matter which order you put them in. It's okay. So we're going to select the first 3 non-repeating numbers. Or you can say select 3 applicants to hire. Repeats are not okay. Or ignore repeats. Because you can't have the same person more than once. What are they doing? My gosh. Okay? And basically what I'm going to do is I'm just going to record how many women were hired in that round. Just by chance. And we're going to see if getting a chance of all 3 of them being women is surprising. Air quotes with surprising. Okay? Now, when I did it, did a whole bunch of trials, the actual probability, and we will get to calculate this probability later on in the school year. Right now, no, I do not expect you to have 7.8% of the time. Just letting you know that the chance of, if this situation arose, of hiring all women would be 7.8%. And for us, we're going to be later defining our surprise level as 5%. So I would say it's kind of weird. It's not really surprising. Okay? And this is what happens a lot of times. And this is how, in a lot of those cases, those equal opportunity will go through and do their calculations. They will say, well, how far off of you from chance? And if it's like, dude, the only way you're hiring only people from specific families who have connections, not very likely. So methinks you have a problem. Okay? So I'm just going to kind of look at a couple of these. If you have 8% of customers for the next problem, and I'm always going to put more problems on here than we get to. Don't worry about it. It's okay. If you want extra practice, you're always welcome to start from the end and work backwards. That's fine. But if I'm looking at this problem, I've got a 15-seater commuter plane, and I have 8% are no-shows. And I want to figure out if I sell 17 seats, am I going to have enough seats for my people? So if I've got 8% no-shows, am I going to be using the numbers 1 through 17 or 0 through 99? Or 0 through 99. Because our characteristic that we're looking at here is whether or not you show. So I would say the numbers 1 through 8 represents a no-show. 9 through 100 or 9 through 99 and 00 represent somebody who showed. I'm going to look at 17 numbers. Are repeats okay for this? We have the numbers 1 through 100. 8% represent those who don't show up. There's an 8% chance that you don't show up. There's an 8% chance that you don't show up. 8% chance that you don't show up. Are my numbers representing individuals? No. The number represents whether or not that person showed. So I can have, like if I get the number 6, that means that I didn't show up. I can get the number 6 when I go and pull something for you. That means you didn't show up. So it's like I've got 17 people, like over here. Each person, I'm going to use my random number generator, get a value that matches that person. And I'm simply going to say, did you show? Did you show? Did you show? Did you show? That's a characteristic. I'm not going to randomly pick 8% of those people. That's the distinction I'm trying to make here. It's the hardest thing to kind of wrap your brains around. How are you doing with that? And again, you want to think, can multiple people, and think about it that way. Think about the number 6. What does the number 6 represent? Represents that somebody did not show. Can I get that number again? Yes. Whereas on the previous one, what did one of those numbers represent? Represented that person getting hired. Can I have that person again? No. Okay. Yes?
So, the problem is going to have 15 people show up.
Nope. Because number one, the question we were asking was, do I have enough seats? So I'm just going to go through all 17 people. Right. So in order for me to have the right amount of seats, I got to have 2 no-shows. I'm going to go through 17, and I'm going to record the number of people who showed up. Okay? Right. Yes. Yeah. A prospective passenger or a ticket purchased. And then you're just going to record whether that person showed up. So 17 tickets were sold. 17 tickets are out there. And airplanes do this. Almost every single flight, they oversell if at all possible. If they can't oversell, a lot of times they cancel the flight. Okay? So they're going to oversell, and they're going to cross their fingers and say, please don't come, please don't come, please don't come. Seriously. Fly a few times. See the anger in the eyes of those who were rejected. Okay? Yes? I'm giving you a table. Makes everybody's lives easier. Okay, so I don't like you either. And my computer has frozen.